So let us do question number 5. A tangent plane to the ellipsoid x square by a square plus y square by b square plus z square by c square equal to 1 meets the coordinate plane in PQR. Meets the coordinate planes. In place of plane, right here axis. Meets the coordinate axis in PQR. Find the locus of the centroid of the triangle. So for this, so to do question number 5, actually a tangent plane to this ellipsoid. So first of all, recall the condition that already we have seen that if Lx plus My plus Mz is equal to P is a plane given to, then this plane, remember this plane will be tangent to central conicoid, if central conicoid ax square plus by square plus cz square equal to 1, if this condition is satisfied, that is L square by A plus M square by B plus N square by C is equal to P square. So this is the required equation. If this plane will be tangent. So use this one is the standard form, but in our case, the equation is x square by A square. If we compare with this equation, so basically here A A is replaced by 1 by A square, B is replaced by 1 by B square, and C gets replaced by 1 by C square. Because in our case, equation of central conicoid is this one, which is clearly an ellipsoid. So this condition will be, if I replace A by 1 by A square, then we have the condition as A square L square plus M square B square plus N square C square is equal to P square. So this is the required condition for tangency for a plane Lx plus MYZ is equal to P. Now if I replace this P by this one, then I can say that a tangent plane, that the plane Lx plus My plus Nz, and in place of P write under root A square L square plus M square B square plus N square C square. This plane is basically is tangent plane to the ellipsoid, because in our case equation is this one, x square by A square plus y square by B square plus z square by C square is equal to 1. Now, so as per question, this plane is going to meet the axis, say at P, Q, and R. Say at P, Q, and R. So how to find its intercept? We know that in intercept form, I need to compare with this equation: x by say A dash plus y by B dash plus z by C dash is equal to 1. Basically, A dash is the intercept on x-axis, B dash is the intercept on y-axis, and C dash is the intercept on z-axis. So if I to write equation in this standard form on right hand side, I need 1. So let us divide by this one. So I can write this equation of plane. I can rewrite equation of plane as x upon under root this. Let me write the coordinates of P as x1, 0, 0. Okay, x1, 0, 0. Okay, I can write this equation as x upon, and I can write 1 upon L, write L as 1 upon L, and this one is under root A square L square plus M square B square plus N square C square. Plus similarly, one can write y upon 1 by M into the root, the term here which is in root, plus similarly z by 1 by n into this root is equal to 1. So you can see that the intercept made on x-axis is this one. Intercept made on x-axis is this one. This one is the intercept made on x-axis. So I can write coordinates of P as 1 upon L under root a square L square plus m square B square plus n square C square, comma 0 and 0, because on y and z we are looking at intercept on x-axis, so y and z will be 0. Similarly, one can write coordinates of q as 1 by m into this root term, and then 0 1 by m into this term which contains this root, comma 0, and coordinates of r. Let us assume that p is on x-axis, q is on y-axis, and r is on z-axis. So 0 0 1 by n into this root term. Now, when coordinates of p, q, r are known, so one can easily find the triangle centroid. So centroid is given by the x coordinates at p, x coordinates at q, which is 0, and this x coordinate at r, which is 0. So dividing by 3, we will get the coordinates of centroid, each x coordinate of centroid. So obviously it will be 1 by 3 of, so coordinates of centroid. Coordinates of centroid. Suppose coordinates of centroids are x1, y1 and z1. So clearly x1 will be equal to 1 by 3 of 1 by 3L of under root a square L square plus m square B square plus n square C square, and so on. Similarly, one can write y1 and z1. I'm not going to write all those terms. Similarly, one can write 1 by m as 1 by 3m into this whole term, and z1 as 1 by 3n into this root. Now, question is, because we have assumed centroid x1, y1, z1. So finally, from the answer, I need to eliminate this x1, y1, z1. So question is how to eliminate this x1, y1, z1 to find the locus of, we need to find the locus of the centroid, and I have assumed the centroid as x1, y1, z1. So how to find locus in terms of the known term? So what we will do for this one? See, x1, y1, z1 is not lying on the central conicoid. This is the coordinates of the centroid. Okay, so it is not lying on the surface of the conicoid. So what we will do, that actually we need to replace element, because if you look in your question, A, B, C are known terms. A, B, C are known terms. So finally our answer should be in A, B, C. If you look, your answer is in terms of, your question is in terms of involves A, B, C. We have assumed, suppose equation of the plane is given by Lx plus My plus Nz equal to this term. This one is a tangent plane to the ellipsoid. So finally, I need to eliminate element, because we need to find locus of centroid. So for locus of centroid, finally I need to replace x1 by x, y1 by y, z1 by z. But how to eliminate element? So for that, what we will do, to eliminate element, okay, let me write here. So to eliminate element, now if you if one can observe that what will be a square x1 square. Look from here, that a square x1 square is, why we are doing a square x1 square, because after writing the term a square x1 square, I am getting here, see, on squaring both sides, if you square both sides, this term, then I have x1 square, and after dividing by a square, actually, if I, let me write here first. See, I have x1 is equal to 1 by 3l into this whole term a square l square plus b square m square plus c square n square. So after taking square and cross multiplying, we have 3l square x1 square is equal to a square l square plus m square b square plus n square into c square. So this implies that x1 square is equal to a square l square plus m square b square plus n square c square whole divided by 3l square. So 9l square. Actually, this one is 9 because we are squaring both sides. Now, I need to use this term. Actually, I need to use this term, this condition. Now, you can see that if you square this lx plus my plus nz whole square is equal to a square l square plus m square b square plus n square c square. N square c square. So, what will happen that uh, if I so this implies that x1 is square 1 upon x1 square is equal to 9 into l square upon a square l square plus m square b square plus n square c square. Now, if I multiply if I multiply by a square on both sides, then you can see we have the term l square a square here. So this is the reason why we are doing this. Because on multiplying by a square on both sides, I have a square by x1 square is equal to 9 times a square l square whole divided by a square l square plus m square b square plus n square c square. Similarly, one can write a square by y1 square using symmetry. So a square by y1 square is again 9 times, no, right, b square m square upon this whole denominator a square l square plus m square b square plus n square by c square. And similarly, the third term. Now look at what we will get on adding. On adding, I have a square by x1 square plus b square by y1 square plus c square by n1 square. Sorry, z1 square. Z1 square is equal to 9. Take 9 common. So here I have a square l square. Here I have b square m square. So in bracket we have a square l square plus b square m square plus n square c square, and denominator is same. I mean a square l square plus b square m square plus n square c square. So you can see that this term get cancelled out. And for locus of x1 y1 z1, replace x1 y1 z1 by x y z. So we will have this equation as in fact here you will get this locus a square by x square plus b square by y square plus c square by z square equal to 9. See, centroid is not lying on the surface of the conicoid. This is the reason. So I cannot so to eliminate LMN, we have to use this technique, because this relation is given to us that a square l square plus m square b square plus n square c square is equal to p square. So by writing equation in this format, actually on adding them, this term will become exactly what the term given in denominator, and it will cancel out. So in this way, we are able to eliminate LMN. And thus for locus of, so you can write that for locus of centroid, for locus of centroid, replace x1 y1 z1 by xy z, and you'll get your answer. Now next is question number 6. Question number 6. Find the locus of the foot of perpendicular from the origin on varying tangent plane. Actually, there is a typing mistake here. Typo on, right here on varying tangent plane. Locus of the foot of perpendicular from origin. Let me write it on the new page. Question is question 6, page number 374. Find the locus of the foot of perpendicular Find the locus of the foot of perpendicular from the origin on varying tangent plane. On varying tangent planes to the surface. X square by a square plus y square by b square plus z square by c square is equal. So one can observe that this basically the surface is ellipsoid. So locus of foot of perpendicular from the origin. So suppose an ellipsoid is given to us. And suppose variable tangent planes are drawn. Suppose these are the variable tangent planes. And from the origin, I have to draw the normals here. Foot of perpendicular from the origin. So basically, I need to compute the locus of this M. Suppose this is the foot of perpendicular M. Then I need to from this origin draw the foot of perpendicular, and I need to locus of these points. So for that, I need to write. So how to do this question? So we have seen, if you recall that then Lx plus My plus Nz will be tangent plane to the central conicoid ax square plus by square. That plus Cz square is equal to 1 if L square by A plus M square by B plus N square by C is equal to P square. But in that case, equation is this one. In our case, central conicoid coefficient of x square is 1 by a square. So this equation will, in case, I mean this x square by a square plus y square by b square plus z square by c square equal to 1. This actually I need to replace a by 1 by a square, b by 1 by b square, and c. So the equation will be a square L square plus m square b square plus n square c square equal to p square. And one can replace p here. One can write a square L square plus m square b square plus n square equal to. So I can replace p in this equation equal to p. Sorry, I can replace this p, the value of p here. So from here I can say that any tangent plane to the given conicoid is Lx plus my plus nz is equal to, in place of p one can write p as under root a square L square L square plus m square b square plus c square m square. And one can write it as equation number 1. So basically this represents this tangent plane. This tangent plane given by equation 1. Now, how to write equation of perpendicular to this plane? Equation of perpendicular to this plane and passing through origin. So for that, I need to write equation of line perpendicular to this plane and passing through. You know, if you recall the equation of plane, then the coefficient Lmn. Basically, these are direction ratios of a line which is already perpendicular to the plane. So that line and this perpendicular will become parallel, and this is the reason why their coefficient will be proportional. So I can directly use this coefficient Lmn. So from here I can say that the equation of perpendicular from origin on this plane is given by x minus 0 upon L equals y minus 0 upon m equals z minus 0 upon n. And suppose this ratio is equal to, say, lambda. Now, what we need to eliminate? We need to find locus of the foot of perpendicular. Locus of the foot of perpendicular, that is m. So that m will be basically obtained by taking intersection of this line and this plane. So equation of plane is given to us, equation of line is given to us. So let me call it as equation number 2. Now, but our equation is, we need to find our equation in terms of the known term a, b, c. So finally I have to eliminate LMN. So if we replace LMN, so this is the reason why we are eliminating LMN. So eliminating LMN. That is replace this L by x by lambda. Write this proportionality constant. This will cancel out from both sides. So on replacing, I will get L by L x by lambda into x plus y by lambda into y plus z by lambda into z is equal to 1 by lambda times. Now replace here L by x. So you'll get a square x square plus b square y square plus c square n is z square. And lambda is non-zero, it will get cancelled out. Therefore, look for non-trivial solution. Therefore, locus of foot of the perpendicular is x square plus y square plus z square. Let me square both sides. So its whole square is equal to a square x square plus b square y square plus c square z square. So this is what required. This is the required answer. So question number 5 and 6 I have completed. Now next is to, in next lecture I will discuss question number 12, 13, 14 and 17. And then we will start classification of central conicoids and equation of normal, how to show that one can draw at most 6 normals to the an ellipsoid. In fact, show that the 6 normals of to the ellipsoid lie on a cone. That one is a very important article, but before that we will do normals from a given point and then some questions based on this. And finally, I will discuss conjugate diameters. So I will share the recorded lecture.